The purpose of this video is to show you how the SovLabs F5 BIG-IP module for vRealize automation works. F5 BIG-IP is a market-leading application delivery platform that enables a myriad of traffic management features that drive application availability and optimization and security. When used in conjunction with the SovLabs F5 BIG-IP module for vRealize automation, you can dynamically create new or use existing F5 BIG-IP virtual servers with blueprint deployments and add linked machine components as nodes, natively integrate with the F5 BIG-IP directly within the vRealize automation blueprint canvas, and dynamically add or remove nodes from the load balancer. Additional features include IPAM and DNS integration, custom naming policies for VIPs and pools, and integration with native F5 BIG-IP features such as iRules, Ssl Profiles, health monitors, and the like. With the F5 BIG-IP module for vRealize automation, the F5 BIG-IP is now a first-class citizen in vRealize automation. By giving you the ability to create and modify VIPs directly in the blueprint canvas, it's never been easier to integrate BIG-IP with vRealize automation. The SovLabs F5 module introduces SovLabs Recipe, an infrastructure as code approach for defining the steps used to create, reuse, remove, and scale F5 structures, such as VIPs, pools, and nodes and members. The SovLabs F5 module comes packaged with a functional recipe with the most common steps and structures. The SovLabs Recipe is a single JSON or YAML formatted script based on the SovLabs template engine. For even more flexibility, use the SovLabs Recipe Guide to create custom recipes. No need for custom vRA workflows to integrate custom vRA properties or interact with other REST-based endpoints. Now let's enter into our blueprint designer. We'll take our blueprint and allow a minimum of 2 servers and a maximum of 4. Now we'll drag in an F5 load balancer and we'll link it to the VM. Next, we'll add the F5 property group to the VM. This is optional, but it will allow us to control additional node level settings. Now we'll save our blueprint and go on to the next step. Let's start by creating a VIP and building a couple of VMs. We'll set the number of instances to 2. For illustrative purposes, we'll set the connection limit to 10, the connection rate limit to 20, the priority group to 30, and the ratio to 40. We'll come back to this later. Now we'll configure our F5 VIP itself. We'll choose our F5 endpoint. We'll also choose the default recipe we wish to use. We're going to tell vRA to create a new VIP on the F5 BIG-IP. We're going to automatically assign and register a virtual name and IP for the VIP in DNS. We will also be using a predefined naming standard for the virtual name of the VIP. Since we're using a subdomain to build these VMs, we're going to register an additional DNS name. We're going to use our default IPAM profile to pick an IP for the VIP. We'll also choose the port we want our VIP to listen on. We have SSL options available to us, but we won't be using those in this demo. We're also going to assign a pool name automatically and allow it to use our predefined naming standard as well. Lastly, we'll choose our load balancing method, which will be round robin. We can see our deployment finished. We're able to see our VIP and the 2 servers that are behind the VIP. Note that the F5 sliders I adjusted earlier for connection limit, priority group, ratio, and connection rate limit are all represented here as vRA properties in the deployment. If I go to my F5 BIG-IP and check my virtual server list, you can see that the VIP has been created. Next, we'll use the scale out feature of vRA to increase the nodes from 2 to 4. Now we can check the pool for my VIP in the F5 and see that I have 4 members instead of 2. What if I want to request new machines and put them on an existing VIP? Let's give it a try and see what happens. As I request 2 new servers, I'll choose the same endpoint and recipe as before, but I'll leave Create New VIP unchecked, and I'll select my name of my VIP from the previous step. When it's done, you can see that my deployment now has 6 members. In such a scenario, what happens if we delete the 2 additional servers that are added to a VIP after the fact? Let's try it and see. You'll notice that once they're gone, the VIP and the other members of the pool are all still intact as one would expect. As we go to request this blueprint complete with servers in a VIP, we'll start by selecting our F5 BIG-IP endpoint and our recipe. Notice that after I select Create New VIP that my partition is pre-selected. This was accomplished by marking the option as read-only in the blueprint configuration. You may have noticed in the earlier steps you don't have to automatically generate host names. You have the ability to manually set host names. Please note that when I'm using IPAM to automatically select the IP of the VIP that we're able to also use the SovLabs IPAM module. When registering to DNS, the SovLabs DNS module is used, and if you were to automatically generate a host name for your VIP, the SovLabs custom naming module would be invoked. You also have the ability to use Ssl Profiles for client, Ssl Profiles for server, and virtual iRules, which contain many predefined rules for common internet services. Any custom iRules uploaded to the F5 BIG-IP instance can also be selected. In this request, you can see that I am able to manually set the name of both the VIP and the pool. You also have a wide selection of load balancing methods to choose from when creating your VIP. Once you've selected one, you can opt to add health monitors as well. These are pre-configured monitors for common internet services. Let's recap the F5 BIG-IP module for vRealize automation. First-class citizen design. Drag directly into vRA blueprint canvas. Associate machine components by linking to the F5 BIG-IP virtual component in the vRA blueprint canvas. Option to reuse an existing F5 BIG-IP virtual server or create a new one. Ability to pin, override, hide request form parameters per vRA composite blueprint, which can also be saved or exported. Supports nested vRA blueprints. Supports vRA scale-in, scale-out for deployments. Select SovLabs recipe to control lifecycle and configuration parameters with full REST-based API support for F5 BIG-IP endpoints. SovLab recipes can be YAML or JSON format. SovLabs recipes can create F5 BIG-IP VIP pool nodes and assign nodes to pool. SovLabs recipes can delete F5 BIG-IP VIP pool nodes and unassigned nodes from pool. SovLabs recipes can use vRA properties defined on the F5 BIG-IP virtual form component in the vRA blueprint. SovLabs recipes can use any dependent machine component properties within the vRA composite blueprint. The ability to specify F5 BIG-IP VIP name, IP address, and port at request time. Option to integrate IPAM and/or DNS for F5 BIG-IP VIP assignment and DNS registration with Infoblox, BlueCat, Microsoft, SolarWinds, Men and Mice, BT Diamond, IP at request time. Supports multiple DNS domains for optional DNS registration at request time. Option to integrate naming standard or sequence definitions for F5 BIG-IP VIPs and pools at request time. Included vRA property group for setting additional node level overrides at the machine component level, such as member port, connection limit, rate limit, priority group, and ratio at request time. The ability to specify one or more F5 BIG-IP Ssl server profiles at request time. The ability to specify one or more F5 BIG-IP Ssl client profiles at request time. The ability to specify one or more virtual F5 BIG-IP iRules at request time. The ability to specify one or more F5 BIG-IP pool health monitors and availability requirements at request time. Multiple vRA VRO instances and multi-tenant support. Request to create an F5 BIG-IP VIP independently or as part of a vRA composite blueprint. SovLabs template engine allows for static text in combination with vRA custom properties and/or custom logic. It's a simple two-step install and upgrade process. Quick start process. Define F5 endpoints, drag and drop and modify the F5 virtual component, and link it to dependent machine components in the vRA blueprint, and provision. For more information on this and all of our other SovLabs modules, please visit sovlabs.com.